we are able to fulfill requirements which help us to move forward, move ahead with decarbonization, lower CO2 footprint, energy saving, so higher energy efficiency, saving of materials due to more compact systems, less cooling efforts, etc.
Hi folks, this is Fabian and you are listening and watching the Podcast for Engineers, the podcast you just have to listen and watch if you're interested in what's going on in the semiconductor market. Today we will be talking about SiC, silicon carbide, and it's my pleasure to introduce you to Milan Ivkovic, who is Director of Analog and Power Technology segment and Technical Support Center Manager of EBV. And also with us is Peter Friedrichs, Distinguished Engineer, SiC of Infineon. Warm welcome to you both.
Thank you.
Thank you, Fabian.
So SiC obviously is a very hot topic. Everybody's talking about SiC, obviously. Where do you see the main applications? Where can you say SiC is mainstream?
Yeah. So we can see several applications today that are already using silicon carbide as established technology. And certainly they are at the first place related to car electrification, so EV charging, onboard chargers. But also we can see in high-end motor drives, like for servo drives or motors that are running on high RPM, which are benefiting from a high switching frequency of silicon carbide. But also we can see it in the solar. We can see different applications that are tied to three-phase networks, so for auxiliary power supplies for 1700 volt switches from silicon carbide, and we can also see it in different power supplies as well.
Okay, well, obviously SiC is hitting the mainstream, but why is this so? What are the main drivers for silicon carbide, Peter?
Yeah, I think the main driving forces are measurable, tangible benefits in the application, especially in the ones Milan already addressed. We are able to fulfill requirements which help us to move forward, move ahead with decarbonization, lower CO2 footprint, energy saving, so higher energy efficiency, saving of materials due to more compact systems, less cooling efforts, etc. These are the major driving forces for the big, let's say, boom about silicon carbide right now. And of course, all connected to a progress in the technology which allows us to scale at affordable costs today.
Milan, anything to add from your side?
I can add maybe some technology, some applications that I didn't mention, where we can see that engineers are starting to think about silicon carbide, like even in heat pumps for reduction of sizes and boosting efficiency. Then also we see it in energy storage applications, and something that is coming. This is solid state relays and solid state fuses, which will enable for energy management in factories, which is really important for carbon footprint.
Okay, SiC has been with us for more than 20 years now. We started with silicon carbide diodes. Where's the technology developing to, Peter? Is there anything, development trends you can see and share with us?
I think the major development trends are in, let's say, in the direction of more application-dedicated products. So the technologies itself are mostly settled. So we see definitely the diode technology as the, let's say, it's already present many years on the market. Further developments we expect, especially in the MOSFET arena. More powerful devices, more optimized material utilization by new device generations. And we also expect that we will see a wider product range looking into higher blocking voltages for certain applications like traction, for instance, but also seeing a bit more diversified spectrum in the arena of classical products, so different housing technologies, maybe also new blocking voltage classes. We have observed that recently with the introduction of 2 kV devices. So that is a trend which we expect to continue, simply triggered by the wide range of existing but also new applications.
So thanks for the insights about the developing. To me, it looks like with the developing we have in SiC, there also will be new applications. Peter, do you see any new applications on the horizon?
Yeah, a few of them have been already mentioned by Milan. What we are also looking into, since it's on the long run definitely also a big opportunity for silicon carbide, is, for instance, the electric aircraft. So here, benefits delivered by this new technology, like significant weight reduction, size reduction, and of course also high efficiency, since also those aircrafts need some energy storage somewhere. So this is something where we expect also not tomorrow, but let's say latest in 10 years, a significant contribution also for silicon carbide based power products. Also, what is an interesting observation we are having right now is that in existing applications, also completely new architectures are enabled. So it's not really, it's a new application, but within an application, like the example of motor drives, where new motor architectures are enabled by the new semiconductors, which are, again, much lighter. They have smaller footprints, better efficiencies, etc. So things which have not been possible with the old silicon technologies now come up again, and this is something where also we expect additional penetrations of wide bandgap, and in particular silicon carbide technologies.
Okay, with more and more applications making use of SiC, with all the engineers out there craving for SiC, there's a growing demand, obviously, but how will the industry serve this demand? Talking about capacity.
Yeah, I think everybody who's a fan of wide bandgap and silicon carbide maybe has followed the announcements over the last months from the major players worldwide. So everybody's investing heavily in capacity in new fabs. So we are trying to keep pace with the really tremendously growing demand. And with the investments we made, so on the Infineon side, we just decided to invest additional 5 billion euro in a fab where we can increase our capacity by about 15 times compared to the today's ones. So this is a speed in growth which is very rare in the semiconductor world, and so it should simply indicate, yes, we do our very best to serve the demand, to grow the capacity, and we expect also from the second half of the decade a relaxation regarding the pull from the market versus the demand we can deliver.
Now, both of you have painted a great picture of SiC. Obviously, for some, this is a new technology. As an engineer, what challenges might you be facing with integrating SiC in an application?
Yeah, you're right, because silicon carbide is replacing IGBTs in existing applications, and I would say topologies as well. And then most of the engineers, they have experience with IGBT, and this is very important to understand what are the differences of the silicon carbide material itself in order to take the maximum of the technology, and also to protect the switch and the system from the events that are unwanted, for sure. So I think that gate driving of the silicon carbide is very important. It is important for engineers to understand that there are different now turn-on, turn-off voltages. There are much higher voltage and current changes in time, so which are inducing some unwanted, like parasitic turn-off through Miller capacitance. So gate drivers which are capable of preventing this are a must in a circuit. Then a special care has to be taken on the layout of the circuit, because now, because of the high DI over DT changes, any parasitic inductance can bring significant impact to the circuit. So layout of the circuit itself, packages that are used, there are a lot of innovations in the packages, and also different driving schemes. Like today we see Kelvin source as maybe like a standard approach to drive silicon carbide MOSFET. And not to forget is also that isolation on the gate driver, because now we have a very high voltage, very high rate of voltage change. So isolation barrier had to withstand. So these are, let's say, common issues that designers that first time start with silicon carbide face, but we are here together to solve this, either with technology from Infineon or with engineering knowledge.
Now that sounds great. Peter, anything to add with regards to challenges?
Yeah, it was already nearly complete, but Milan listed up. Maybe two things come up immediately to my mind, also based on the experience I personally had over the last years when implementing silicon carbide in technologies which have been dominated by IGBTs so far. One is very often as system architecture change is connected to the implementation of silicon carbide. So what I mean is traditionally in high power applications, people were used to have bus bars with screws and let's say really solid mechanics behind. And to get the best out of silicon carbide, the optimum way is to move away from bus bars into power PCBs, so avoiding any screws and high inductance connectors. So this change is something where engineers need education and support. That's what Milan mentioned, what we have to deliver and give them. And the second aspect, which is definitely also a big topic in the discussion right now, is that silicon carbide typically has not such a solid short circuit withstand time compared to silicon IGBTs. Also modern silicon IGBTs now come along with shorter short circuit withstand times, but this is definitely something we need to manage in applications where this seems to be a must. But here again, with a proper driving scheme around fast detection and turn off schemes, I think good measures are already available, more to come. But again, it's something where designers need to adapt to the new technology in a bit different way than they are used to have or to do in silicon.
Milan, you mentioned products, you mentioned know-how. How is a customer, potential customer, profiting from this cooperation between Infineon and EBV?
Yeah, as we mentioned already here, there are two challenges. First one is switching from, most probably from IGBT to silicon carbide. So this is engineering challenge. And the other is a supply chain challenge, for sure. So we are here together to help on both sides. Us as EBV, as a first line of support facing the customer, with really good connection with the Infineon applications teams. And then on the other hand, our sales and supply chain that is tightly connected to Infineon. So I think this is something, this synergy that is helping customers really to go further with the silicon carbide.
Yeah, we are very happy to have EBV on board. So it gives us a much wider access to customers, a much better feedback loop, much more than we can do alone. So for that reason, yeah, it's a very fruitful cooperation. And we look forward to continue with that, to be more successful also with silicon carbide in the future. So thanks for that. Yeah.
Peter, thanks for joining this podcast. Milan, thanks for joining. This concludes our podcast on silicon carbide. Stay tuned, there's more to come.